Imagine, if you will, a world lit only by firelight and powered by muscle. Your life's path would be set by the rising and setting of the sun and the changing of the seasons. For most of human history, this was reality. The world was vast, travel was slow, and the work of 1,000 hands might only produce what, well, one machine can do today. Then, something extraordinary happened. A great change swept across the planet, a period we now call the Industrial Revolution. It wasn't a war fought with soldiers and swords, but a revolution of ideas, inventions, and energy. It began quietly in Great Britain around the year 1760 and would continue to reshape our world for the next century and beyond, a cascade of innovation that continues to ripple through our lives even now, on this day, the 6th of October, 2025. This enormous transformation was not a single event, but a chain reaction of discovery. It was a time when human ingenuity was unleashed on an unprecedented scale. We learned to harness new sources of power, far greater than any animal or person could provide. We invented machines that could spin thread, weave cloth, and forge metal with breathtaking speed and precision. This shift from making things by hand to making them with machines is the very essence of the Industrial Revolution. It marked the most significant change in how humans lived since the agricultural revolution thousands of years earlier, when we first learned to farm the land. This new revolution would take us from the farm to the factory, from the village to the city. The Industrial Revolution was fundamentally about energy. Before this period, our primary energy sources were biomass, wood we could burn, and the power of our own bodies, supplemented by domesticated animals. We also harnessed the wind for ships and the flow of water for simple mills. But these sources were limited and often unreliable. The revolution began when we unlocked the immense concentrated energy stored in fossil fuels, starting with coal. By burning coal, we could boil water to create steam, and that steam, under pressure, could be used to drive powerful engines. This single concept, turning heat into motion, was the engine that powered the entire era, a fundamental shift in our relationship with the planet's resources. We can think of this period as humanity learning a new cosmic language, the language of physics and chemistry. We began to understand the laws of nature not just as philosophical ideas, but as practical tools. The scientific mindset, which had been growing since the Renaissance and the Enlightenment, was now applied to everyday problems of production and transportation. How can we make stronger metal? How can we travel faster? How can we communicate over long distances? The answers to these questions gave birth to the modern world. They built the foundations for the technologies we rely on today, from the electricity that powers our homes to the global networks that connect us all. The Industrial Revolution was the moment we started building our technological civilization. The story of the Industrial Revolution often begins with a simple, everyday material: cotton. For centuries, making cloth was a slow, labor-intensive process done in people's homes, a so-called cottage industry. Families would spin wool or cotton into thread by hand and then weave that thread into fabric on a small loom. It took many spinners to supply a single weaver with enough thread to keep them busy. This system had existed for generations, producing just enough cloth for local needs. But a growing population and expanding trade created a demand for more textiles, a demand that the old ways simply could not meet. This created a bottleneck, a puzzle waiting for an ingenious solution. The first domino fell with a series of brilliant inventions in the British textile industry. In 1764, James Hargreaves invented the spinning jenny, a machine that allowed one worker to spin multiple spools of thread at once. Suddenly, the productivity of a single spinner multiplied. This was followed by Richard Arkwright's water frame, which used the power of a flowing river to spin stronger, more consistent cotton thread. Then came Samuel Crompton's spinning mule, which combined the best features of the jenny and the water frame to produce high-quality thread in massive quantities. The bottleneck in spinning was shattered. Now, the problem was reversed. Spinners could produce thread faster than weavers could turn it into cloth. The solution to the weaving problem arrived with Edmund Cartwright's power loom in 1785. Though it took a few decades to perfect, this machine mechanized the weaving process, dramatically increasing the speed and scale of cloth production. These new machines were large, expensive, and required a centralized power source, like a water wheel or later a steam engine. It was no longer practical for work to be done in scattered cottages. Instead, workers had to come to the machines. This led to the birth of the factory, a building dedicated to mass production, where hundreds of people worked together under one roof, their days governed not by the sun, but by the factory whistle and the relentless rhythm of the machines. This shift from home to factory was more than just a change in workplace. It was a fundamental reordering of society. The factory system introduced new concepts like wage labour on a massive scale, the division of labour into small repetitive tasks, and the disciplined schedule of the workday. People who had once been independent artisans or farmers became factory workers, their livelihoods dependent on the factory owner. This new system was incredibly efficient, capable of producing textiles and other goods on a scale never before imagined. It was the blueprint for modern industry, a model of production that soon spread from textiles to countless other sectors, forever changing the nature of work. If the factory was the body of the Industrial Revolution, then the steam engine was its beating heart. While early factories were often built alongside rivers to harness water power, this limited their location and subjected them to the whims of nature, like droughts or floods. The true key to unlocking industrial potential was a power source that was reliable, powerful, and could be located anywhere. That key was steam. The principles of steam power had been known for some time, but early engines were inefficient and used mainly for a single purpose: pumping water out of deep coal mines, which were themselves essential for providing the fuel for the revolution. The breakthrough came from a Scottish instrument maker named James Watt. In the 1760s and 1770s, Watt didn't invent the steam engine from scratch, but he radically improved it. He introduced a separate condenser, a crucial innovation that allowed the main cylinder to remain hot at all times. This made the engine dramatically more fuel efficient, saving vast amounts of precious coal. More importantly, Watt developed a way to convert the simple up and down pumping motion of earlier engines into a rotary motion, like a spinning wheel. This was the game changer. A steam engine could now be used to turn the gears and drive the belts of any machine you could imagine. With Watt's rotary engine, the factory was finally untethered from the riverbank. Industries could now be built in cities, close to labour, suppliers, and markets. The steam engine provided the tireless, constant power that the new machines demanded. It drove the power looms in textile mills, operated the bellows in iron foundries, and powered the mills that ground grain into flour. The rhythmic chugging of the steam engine became the soundtrack of the 19th century, a constant reminder of humanity's newfound mastery over energy. It represented a fundamental shift from relying on the gentle, diffuse power of nature to commanding the intense, concentrated power locked away in the Earth's fossil fuels. The impact of the steam engine extended far beyond the factory walls. It was a universal power source, a prime mover that could be adapted for countless applications. Its most transformative use would be in transportation, powering locomotives and steamships that would shrink the globe. But its influence was felt everywhere. It enabled larger-scale mining by pumping mines deeper, which in turn provided more coal to fuel more steam engines. This feedback loop, more coal leading to better engines leading to more coal, was a powerful accelerator of industrialization. The steam engine was not just one invention among many. It was the central technology of the age, the force that amplified all other innovations. Every revolution needs a strong framework, and for the Industrial Revolution, that framework was forged from iron and steel. For centuries, iron had been a valuable material, but producing it was difficult and expensive. The traditional method used charcoal, made from wood, to smelt iron ore. This process was slow, and the massive consumption of wood led to widespread deforestation. The iron produced, known as cast iron, was brittle, while the stronger wrought iron was costly and time-consuming to make. To build an industrial world of machines, bridges, and rails, humanity needed a way to produce vast quantities of strong, cheap metal. The first major breakthrough came in 1709, when Abraham Darby discovered a way to use coke, a purified form of coal, instead of charcoal to smelt iron ore. Since coal was far more abundant than wood, this innovation dramatically lowered the cost of iron production and freed it from the limitations of forest resources. This made iron cheap and plentiful enough to be used in new and exciting ways. It became the material of choice for building the steam engines, factory machines, and water pipes that were essential to the growing industrial landscape. The age of iron had truly begun, providing the bones for the new industrial civilization. Even with cheaper iron, there was still a need for a stronger, more versatile material. The answer was steel, an alloy of iron and a small amount of carbon. For most of history, steel was an expensive luxury, produced in small quantities for things like swords and fine tools. The challenge was to find a way to make it on an industrial scale. In the 1850s, an English inventor named Henry Bessemer developed a revolutionary technique. The Bessemer process involved blowing air through molten iron to burn out impurities and control the carbon content. This simple, fast method could produce tons of high-quality steel in a matter of minutes, a task that previously took days. The arrival of cheap, mass-produced steel changed the world yet again. Steel was both stronger and more flexible than iron. It allowed for the construction of longer bridges, taller buildings, and more durable rails for the expanding railway networks. It was used to build stronger ships, more powerful boilers, and more precise machinery. The iconic structures of the late 19th century, from the Eiffel Tower to the Brooklyn Bridge, were monuments to the new age of steel. The ability to create new materials, or to produce old ones on an unprecedented scale, was a hallmark of the scientific and engineering mindset that drove the revolution forward, building a stronger, more connected world. The Industrial Revolution created a massive increase in the production of goods, but this created a new problem: how to move all these products from the factories to the markets. And, how to transport the raw materials, like cotton and coal, to the factories in the first place. The old methods of horse-drawn wagons on muddy roads and slow barges on canals were no longer sufficient. The same spirit of innovation that transformed the factory floor was soon applied to the challenge of transportation, leading to inventions that would shrink distances and knit the world together like never before. The world was about to get a whole lot smaller. The first great leap forward was the steam-powered locomotive. Building on the twin technologies of the steam engine and iron rails, pioneers like Richard Trevithick and George Stephenson developed practical iron horses. In 1825, the Stockton and Darlington Railway in England became the first public railway to use steam locomotives, and the age of the train was born. Railroads could move heavy loads of coal, iron, and finished goods over land with unprecedented speed and reliability. They were not dependent on weather or seasons. A network of iron rails quickly spread across Great Britain, then Europe, and then North America, connecting inland cities to coastal ports and opening up vast new territories for settlement and resource extraction. At the same time, steam power was also conquering the seas. While sailing ships had connected the continents for centuries, they were at the mercy of the winds. The first steamships were initially used for coastal and river transport, but as engine technology improved, they began to make oceanic voyages. Robert Fulton's demonstrated the commercial viability of steamboats in 1807. By the mid-19th century, steamships with iron hulls were regularly crossing the Atlantic Ocean in a fraction of the time it took a sailing vessel. This made international trade faster, cheaper, and more predictable, weaving a tighter web of global commerce and connecting economies on opposite sides of the planet. The revolution in connectivity wasn't limited to the movement of physical goods. It also transformed the speed of information. In 1837, Samuel Morse developed the electric telegraph, a device that could send coded messages as electrical pulses along a wire. For the first time in human history, information could travel faster than a person. A message that once took weeks to cross an ocean by ship could now arrive in minutes. By the 1860s, a transatlantic telegraph cable connected North America and Europe. This instantaneous communication was revolutionary for governments, businesses, and the press, allowing for the coordination of global trade, diplomacy, and news on a scale previously unimaginable. The pull of the factory was honestly just irresistible. As the factory system replaced cottage industries and agricultural work became more mechanized, millions of people left the countryside in search of a new life. They flocked to the places where the factories were being built, a mass migration that caused cities to grow at an explosive rate. This process, known as urbanization, was, without a doubt, one of the most dramatic social changes of the Industrial Revolution. Small towns and quiet villages ballooned into bustling, crowded industrial centres. Cities like Manchester in England, for example, saw their populations multiply several times over in just a few decades, becoming the world's first industrial cities. This rapid, unplanned growth created enormous challenges. The new industrial cities were, quite frankly, often chaotic and overwhelming places. Housing for the influx of workers was built quickly and cheaply, resulting in cramped, unsanitary tenements packed into narrow streets. Basic public services that we take for granted today, like clean water supplies, sewage systems, and garbage collection, were almost non-existent in the early industrial cities. Overcrowding and poor sanitation became a breeding ground for diseases like cholera, typhoid, and tuberculosis, which spread rapidly through the densely populated neighborhoods, making life for the urban poor often short and brutal. Life in the city also gave rise to a new social structure. At the top was a growing and increasingly wealthy industrial middle class, the factory owners, bankers, engineers, and merchants who profited from the new economy. They often lived in comfortable suburbs, far from the smoke and squalor of the industrial districts. Below them was the vast, new urban working class, or proletariat. Their lives were defined by long hours of repetitive labor in the factories, mines, and mills, often in dangerous conditions and for very low wages. This stark division between the wealthy owners of capital and the poor wage laborers created new social tensions and conflicts that would shape political life for centuries to come. Despite the hardships, the city was also a place of new opportunities and cultural change. It was a melting pot where people from different backgrounds came together, sharing new ideas and experiences. The concentration of people and wealth in cities supported the growth of new institutions like museums, theatres, public parks, and professional sports. The city became the centre of modern life, a dynamic and complex environment that was both a source of immense suffering and a crucible for new forms of social organisation, political movements, and cultural expression. The very idea of what it means to live in a community was being redefined in the streets of the industrial city. The Industrial Revolution didn't just change how things were made, it fundamentally rewrote the rules of the entire global economy. The old economic order, largely based on agriculture and land ownership, gave way to a new system, industrial capitalism. In this system, the primary means of creating wealth was not farming, but the ownership of capital, the money, machines, and factories used to produce goods. A new class of capitalists and entrepreneurs emerged, who invested their money to build factories and infrastructure, seeking to generate profit by producing goods more efficiently and selling them on a wider market. This created a dynamic, competitive, and constantly expanding economic engine. And this new engine had an insatiable appetite. The factories of industrial nations like Great Britain required vast quantities of raw materials: cotton from the American South and Egypt, wool from Australia, iron ore from Sweden, and timber from Canada. At the same time, the incredible productivity of the factories created a surplus of manufactured goods, textiles, tools, and machinery that needed new markets. This dual need for raw materials and new customers drove an unprecedented expansion of global trade. The new steamships and railways provided the physical means to sustain this global network, connecting producers and consumers across vast distances. The economic balance of power in the world shifted dramatically. Nations that industrialized first, particularly Great Britain, gained an immense economic and military advantage. They became the workshops of the world, exporting their finished goods across the globe. This often led to a new form of global inequality. Many regions in Asia, Africa, and Latin America were integrated into the global economy not as industrial producers, but as suppliers of raw materials and agricultural products for the industrial nations. This created a relationship of economic dependency, where the economies of non-industrialized regions became shaped by the needs of the industrial powers, a pattern that would have long-lasting consequences. The economic philosophy that accompanied this era was one of laissez-faire, a French term meaning let it be. Thinkers like Adam Smith argued that economies worked best with minimal government interference, allowing the invisible hand of the free market to guide supply and demand. This ideology favored the entrepreneurs and capitalists, encouraging investment and innovation. However, it also led to unchecked exploitation of workers and the environment, as the pursuit of profit often overshadowed social welfare. The economic system born in the Industrial Revolution, with its emphasis on capital, growth, and global markets, created immense wealth and progress, but also generated deep inequalities and new social problems that we are still grappling with today. While the Industrial Revolution brought forth incredible technological progress and economic growth, these advances came at a significant human and environmental cost. For the millions who traded the farm for the factory, life was often a grueling struggle for survival. Work in the new industrial setting was radically different from agricultural labor. The hours were long, typically 12 to 16 hours a day, 6 days a week. The work itself was often monotonous, repetitive, and incredibly dangerous. Factories were filled with fast-moving machinery with few safety guards, and accidents that resulted in lost limbs or even death were tragically common. The air was thick with dust and fibers, leading to chronic lung diseases. The impact on family life and social structures was profound. In the pre-industrial world, families often worked together as an economic unit on the farm or in a home-based craft. The factory system broke this apart. Entire families, including very young children, were often forced to work in factories and mines just to earn enough to survive. Child labor was widespread and particularly brutal. Children were valued for their small size, which allowed them to crawl under machinery, and for their low wages. They endured the same long hours and dangerous conditions as adults, deprived of education, play, and a healthy childhood. These harsh conditions eventually sparked outrage and led to the rise of labor movements and calls for reform. The revolution also had a profound and lasting impact on our planet's environment. The new industries were powered by burning massive quantities which released enormous amounts of smoke and soot into the atmosphere. The skies over industrial cities were often black with pollution, and a layer of grime covered everything. Industrial waste and untreated human sewage from the overcrowded cities were dumped directly into rivers, turning them into toxic, lifeless waterways. This was the beginning of industrial-scale pollution, a problem that has grown in complexity and scope over the last 2 centuries. The Industrial Revolution marked the point where human activity began to alter the planet's chemistry and ecosystems on a global scale. In response to these social and economic upheavals, new ideas and cultural movements emerged. Some, like the Romantics, reacted against what they saw as the soulless, mechanical nature of the new industrial society, celebrating nature, emotion, and the individual. Others developed new political and economic theories to explain and address the changes they were witnessing. Thinkers like Karl Marx analyzed the new class structure and predicted a future conflict between the bourgeoisie and the proletariat. The social strains created by industrialization gave birth to socialism, trade unionism, and calls for government regulation to protect workers and the poor, setting the stage for the major political debates of the modern era. The Industrial Revolution was not an event that simply ended in the 19th century. It was the beginning of a continuous process of technological and social transformation that defines our world to this day. The fundamental changes it set in motion, the harnessing of new energy sources, the rise of the factory system, mass urbanization, and the creation of a global economy, are the very foundations of modern civilization. Every time you flip a light switch, travel in a car or plane, or use a device manufactured on the other side of the world, you are experiencing the direct legacy of the innovations that began in a few British textile mills over 2.5 centuries ago. The scientific and engineering mindset that flourished during the revolution is now more powerful than ever. The relentless drive for innovation continues to produce new technologies at a dizzying pace, from computers and the internet to artificial intelligence and biotechnology. This ongoing technological revolution, sometimes called the second or third industrial revolution, is a direct descendant of the first. It continues to reshape our economies, our societies, and even our understanding of what it means to be human. The habit of applying scientific principles to solve practical problems, established during the Industrial Revolution, has become the primary engine of change in our time. However, we have also inherited the profound challenges that began in this era. The social inequalities between the wealthy and the poor, which became so stark in the industrial cities, remain a central issue in nearly every society on Earth. The model of an economy based on continuous growth and consumption of resources has led to unprecedented prosperity for many, but it has also brought us face to face with global environmental crises, most notably climate change, driven by the same fossil fuels that powered the first steam engines. We are now grappling with the long-term consequences of the industrial model on a planetary scale. As we stand here today, on the 6th of October, 2025, we are living in a world forged by the Industrial Revolution. Its legacy is a complex tapestry of incredible progress and daunting challenges. It gave us the tools to build a global civilization of immense complexity and power, but it also created social divisions and environmental pressures that threaten our future. Understanding this pivotal moment in human history is essential for understanding ourselves and the world we have built. The story of the Industrial Revolution is the story of how we became modern, and it serves as a powerful reminder that the choices we make about technology, energy, and society will echo for generations to come.